Hello there, my name is David Kidder. In this video we're going to be taking a look at sine waves, exactly what's going on, the basics of what makes up a sine wave and why it is that we use them. Alright, so they're a very basic concept. Really what they are is a representation of a cyclical event. So for example, what does that mean exactly? If you have a generator and it's rotating around, and you've got a north pole here and a south pole here, you've got a set of windings, which is a coil, and everything is kind of just rotating around inside there. You're going to have your coils and they're going to be crossing north poles and crossing south poles. And every time they do, they're going to have a positive polarity or a negative polarity. And you're going to just have that generator spinning around or an alternator spinning around, how many ever times a second. And what happens is you get a positive voltage and a negative voltage, a positive and a negative and a positive and a negative, and it's kind of a cyclical event that happens over and over again. So what we do is we use sine waves in order to sort of graph out what's happening inside this system so that we can gain a better understanding of what happens. So as we cross that north pole, we get that positive bump of voltage, and then we pass that north pole and kind of drop off. Then when we come across that south pole, we have a negative bump of voltage, and then as we kind of come around, we drop off again. Okay, so this is kind of what we're talking about. We have a sine wave that is developing every time we make a full revolution across a couple of poles, a north and a south. So what does that really mean then? What it means is at moments in this graph, we have 0 volts being developed. We've got some sort of a max, or another term is a peak voltage, and that's a peak positive voltage. We also have another period of time here where we have 0 volts present. Here, we've got that negative peak, and then we finish off as we kind of come down back to 0 volts. So that's what you call one full cycle, where you have one positive alternation and one negative alternation. So one of these positive bumps and one of these negative bumps, each one is an alternation. That's where we've gone from here, we've come around to here, then we go from here to here. Well, that's one alternation, another alternation, but that's one complete cycle as you go around that entire system. Okay, so that's really what a sine wave is. It's just a graphical representation of what's going on inside this generator. And you can see that, there's a lot of moving parts and there's a lot of fields, and if we start to add more and more poles, more norths and souths and more windings, make it go from a single phase to a 3-phase system, it starts to be very complicated to look at and almost not impossible, but very difficult to understand. So if we use a graph like a sine graph and we graph it out, it becomes a lot easier to compare different values within that system, okay? So we could have multiple voltages, multiple currents, and we could really start to understand how the system is behaving cycle for cycle, moment for moment, okay? So a couple of things about this, just to wrap up. When we made one full revolution, we went 360 degrees. So one full sine wave will be 360 degrees. So that would mean we're at 0 degrees here. Here we're at 90 degrees at the peak. Down here we're halfway, so we're at 180 degrees. Here we're at, 270 degrees, and then we get to 360. Okay, so from 0 to 90, we're rising in the positive. From 90 to 180, we're decreasing in the positive. From 180 to 270, we're rising in the negative. And then from 270 to 360, we're decreasing in the negative. And then we start all over again at 0, and that starts the sine wave again. Okay, so it's just really, it's kind of understanding that we've got something that's occurring in a circular motion here, and it's cyclical, and it's happening again and again and again every single time. So we just use a sine graph in order to do some calculations and understand the complex relationship of what's going on in that circuit. Okay, so thank you for joining me, and we'll see you in the next video.